Hello, everybody. We are on day 14 of our digital learning, and we've been talking this week about skew, and we've been talking about outliers and box plots. And I want to expand our discussion to include not just skewness in box plots, but today to look at skewing histograms and also dot plots. And we'll also look at a frequency curve. And this is a different kind of model, but it's actually really, really easy to understand. So I'll show it to you here as we are looking at skew. So here are our notes for today, and you can see here that we have our main focus today is on viewing these different distributions, and I'm starting with a histogram because remember, a histogram is very similar to a dot plot. You might just have a dot plot is really kind of the same thing. It's just instead of these bars, we have dots. Okay, so like as you can see, I'm drawing here on this first one. If it were a dot plot, it would look essentially the same, except there would be dots instead of bars. And that's really it, okay? But the other thing I want to point out here is that notice one thing that we can do to kind of get a more continuous view of the distribution is you see this dotted line is drawn to the corners of the bars of the histogram. That creates what we call a frequency curve. And again, it's really kind of obvious if you just look at it and think about it. It's just like the histogram. You just don't see the bars. This would kind of be like if we had our histogram here and then we threw a big sheet over the whole thing and we just saw it laying on top. This is what we would see. Okay, so all that to just get us to the point where what we want to look at here are the distributions. Okay, now when something is distributed, it's sent out, it's delivered. Okay, and basically what we're looking at in distributions is we're talking about data that has been delivered to the different values, and we're looking at how many of each one we have and looking at that shape. All right, so we already talked about this with box plots, but I wanted to see what this looks like here with histograms and then do several examples with you. Okay, so I'll start in the middle here. Symmetric. Symmetric is when we have the majority right here in the middle, and then things are generally evenly distributed on either side. So here we have the middle bar in our histogram, and then on either side there's about the same amount. In this case, it's a perfect symmetric example, but they can be a little bit different as long as they're relatively the same, and we could still call it a symmetric distribution. Okay, and a perfect symmetric one has this description here. The left side, if we were to draw a line right down the middle here, the left side is a mirror image of the right-hand side, kind of like our parabolas that we looked at earlier in the year. We have this mirror image on either side of the middle, okay? Now, the reason why this is significant is because it's symmetric because the mean is going to be approximately the same as the median. Okay, we've been talking about mean and median a lot, median especially with our 5-number summaries and their quartiles with the box plots. But here, the mean and the median are approximately the same thing. When we're talking about something being skewed, remember we're talking about the mean being pulled to one side or the other. So when we're talking about skewed left, what we're talking about is, okay, the median might be somewhere around here, okay, or maybe even It might even be something like this. Okay, so there would be our median. But the mean, because of these low values, this tail on the side, we have this tail extending to the left, but most of the data is on the right. Our mean would get pulled over to the left to somewhere maybe around here, okay? Yes, these high values here do keep it up somewhat, but these exceptionally low values down here pull the mean to the left, okay? This is like when, let's say, you are trying to determine how good your soccer team is, okay? And you're rating everybody, and everybody's doing pretty well. You got a few who are really really good, but then you've got a couple guys on the team who just aren't getting it. All right, they're doing very poorly. And if we were to just take a mean of everybody's performance, the mean would be lower because of these few guys who are really doing poorly. If we look at the median instead, it shows that things are a little bit better than they might seem. Okay. Now, on the other hand, we also look at skewed right, data that is skewed right. Okay. So on our histogram, we can see, the median might be somewhere around here. Okay. The median somewhere around here. But the reason why we call this skewed right is because we've got this tail on the right-hand side. All right. But most of the data are on the left. But this tail on the right-hand side has particularly high values, and that's going to pull the mean. The mean might be somewhere like this, right there. Okay. The mean is right there. So that's the idea. Now, there is a little tip over here. Okay. If everything is about the same, we call this a uniform distribution. That would be like if we had a histogram that looked something like this. And they don't have to be all the same, but they're all basically the same. If we had something like this, that would be approximately a uniform distribution. Okay. Now, this is a special case of symmetric because, if everything is the same, then the left side is the same as the right hand side. But you can see there's not really a distribution where more of the data is in the middle or more is on one side or the other. Okay. We're not going to talk about that too much, but I figured it was worth pointing out to you. Okay, so let's work through a couple of examples real quick just to identify the skewness or symmetry in several distributions. Okay, so here we have a dot plot. Here we have the daily snowfall amounts. We're not used to this in Georgia, but where I grew up in Ohio, we might see something like this. But we have several days. 2 days we had no snow. One day there was 5 inches of snow. Another 2 days there were 4 inches of snow, and so on. All right. Most of the data, though, are down here. Okay. But these couple of high values are going to skew the mean to the right. Okay. So the distribution here is skewed right. Okay. It's skewed right. So the mean might be somewhere around here. Now, I'm not going to do this on all of them, but I actually, since there's not a whole lot of data, and this is a pretty easy one to do, I'm actually going to show you the values that we have, okay? The mean and the median. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 days. Okay, so there's 21 days. And that means the median is going to be the 11th. Okay, the median is the 11th item in the data set. So if we start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all right, the median equals 2. All right, so that's 2. That's our median. Our mean, however, I need to add up all the values, okay? So let's find the mean here. The mean, we have 2 zeros, okay? 2 times 0. We have 1, 2, 3, 4, 5, 6, 7 ones. So 7 ones. We have 6 twos. 6 times 2. Plus there are 3 threes. Plus there are 2 fours. So 2 times 4. Plus there's 1 5. Okay, so I'm adding up the values here. If I do that, I get 0, 2 times 0 is 0, 7 times 1 is 7, 6 times 2 is 12, 3 times 3 is 9, 2 times 4 is 8, and then we've got the 5, okay? So I add all those up now, and I get 19, 28, 36, 41. So the mean equals 41 divided by 21. Okay, 41 divided by 21. See if I did that right. Okay, and if I do that actual division, bring up my calculator here, just for speed. 41 divided by 21, we actually get 1.95. Now this might seem kind of odd. Okay, that's 1.95. All right. Our mean actually ended up being slightly lower than what the median was, but that was simply because we have so many ones. There weren't quite as many up here to pull it all the way. But if this had been symmetrical, then our mean would have been probably closer or somewhere between 1 and 2 instead, okay? So the mean gets pulled to the right a little bit in this case, okay? Now, we're not going to do that on all of these, so let's move forward here. Here, notice we've got the passes thrown. If I were to make that kind of curve that we talked about, all right, you see here the curve. This isn't perfect, but you can see that it's approximately the same on either side. Okay, this side is a little higher than this bar is a little higher than this, but these are about the same. Okay, we could say that this distribution is symmetric. Okay, symmetric. Couple other examples here. Here, if we were to draw a bar graph, okay, notice we are given the ranges of age, okay, and we want to use this frequency table to draw a bar graph, or I'm sorry, draw a histogram. So let's actually do that. All right, so I'm gonna do this down here, okay. So we have our 10 to 13 range, and just for ease, I'm going to label these A, B, C, D, E, F, and G. Okay, so we have A, B, C, D, E, F, and G. And we also have a vertical axis here. Come on. Doesn't want to stand up straight. Let's try this. That's close enough. All right. So notice our frequency goes from 1 up to 20 and then down to 3 again. So you know what? I'm going to go ahead and mark my axis over here going by, let's say, fives. Okay. So here's 5, 10, 15, and 20. Okay. So A only has 1. So the bar here, that's probably even too high. The bar here is only going to go up this high. Okay. So there is A. And then B goes up to 3. So to that high. Okay. C is 7. So we'll go up to about here. And you notice here, guys, as I'm sketching this, these don't have to be perfect, just approximately accurate, and you'll get a good idea of what these look like. Okay, so D is 12. D is 12. E goes all the way up to 20. You know what? I'm going to pull this over a little bit just so we have some more room. Okay. I'll pull these over actually too. There. Oh, up into our G. Okay. So E goes all the way up to 20. F goes up to 18, so a little bit shorter. And then G is back down to 3. So that's the same height as B over here. But you'll notice here, even with this rough sketch, you'll notice that the majority of our data is over here on the right. In fact, if we were to sketch the curve here, notice we have it rising quite high here on the right-hand side, and we've got this tail to the left. So that means our mean is going to be skewed to the left. So this distribution we would say is skewed left. Okay. Now, I sketched this just for some extra practice in sketching these by hand because we haven't done much of that. But you'll notice my drawing over here matches the histogram we've got over here. Okay. Now, example 3, we have the ages of people watching an animated movie. So we have the same theater. This was a movie theater, people attending a comedy. All right. So here they're attending a comedy, and this is the ages of people who are in there, how many people went to that movie. Here we have animated. As you would expect, notice there are a lot more younger people watching the animated than over here watching the comedy. Okay, typical, makes sense. All right. If we're describing the shape of the distribution, though, notice this one, there's a lot more lower ages, and then only a few older people, maybe taking their kids or something like that, going to the animated movie. So this distribution is going to be skewed right because we've got that tail on the right that's going to pull the mean to the right of where most of the data is. Okay, so which movie has an older audience? We already saw this, already mentioned this just a moment ago, but notice here we have generally older folks than here. In fact, if we wanted to, we could actually lay this histogram on the same graph and you would actually see it would look like this. Okay. So the comedy has an older audience. Okay, so I've given you some practice. First of all, these vocabulary, don't skip these. I want you to explain a little bit. Put some of this in your own words. On the Google form, I made it paragraph, all right? Use complete sentences, express your thinking here. How does the shape of a symmetric distribution differ from the shape of a skewed distribution? Okay, so here we're not talking about left or right, but how does symmetric differ from skewed either way? And then for a distribution that's skewed to the right, which direction does the tail extend? Where do most of the data lie? So again, just trying to get you expressing some of what we just talked about in your own words. And then down here, a couple of these, you need to make a dot plot of your own and describe the distribution. And then these other ones down here, these four, you're given the dot plot or the histogram. And then this last one, I split it into 3 separate problems on the Google form. But you're actually comparing 2 different histograms. You're going to draw yourself a histogram, explain or describe the distribution for each one, and then use that to determine which county's police force overall has less experience. Okay, don't jump to the conclusion without actually seeing the graph. Okay, so that is all we have for today. You have some practice. Next, tomorrow, we're going to be having a little quiz over all of this and see how you're picking up on this. That'll be on USA Test Prep. But do your best. Keep working hard. I know this is different, but keep working hard. Log into our Google Meets. Only a few people have been doing that, and I think it's been really valuable for them. But I'd love to see more of you coming in, and also those of you who haven't actually submitted assignments, make sure that you're submitting those, okay? So I can grade what you have and see how great you're doing, okay? So please, I hope you have a great day. Hope you're doing well, and hope to see you soon. All right, bye.